are not a reversible reaction. Okay, now that you know Ka, so here's again a general dissociation reaction for a weak acid. And it's dissociating to make the hydronium ion, and there's the conjugate base, A-. And here's Ka. Here's our Ka expression that we just talked about. Concentration of products over concentration of reactant, which is the weak acid. So how can we look at Ka and learn some stuff? Ka actually communicates several important things for us. Well, number one, Ka tells us about the strength of an acid, okay? The larger Ka, let's think about this, the more products we have, okay? So, for example, if we, after all this dissociates and we reach equilibrium, if we have a concentration of like 0.02 molar here, and remember, we're not including the concentration of water, and let's say we have larger values, larger concentrations for our products. Let's say we have like 1.2 molar, and let's say we have like 1.5 molar over here. Okay, if we have more dissociation, and what that means is at equilibrium we have a higher concentration of our products, then we'll have a larger Ka value because we'll have larger numbers up top, and we'll have a smaller number on the bottom. And anytime you divide a large number by a really small number, you get a large Ka value. Okay? So, back to the second point here. The larger Ka, the more products that we make. Well, what does that mean? Let's read statement 3. Remember that our products indicate how much dissociation. We don't get any of our products unless the acid dissociates. So, the more products we have, the more dissociation we have. So the product is the dissociation. So the larger the Ka, the more dissociation we have from our acid. The more the acid is dissociating, we'll put it that way. And then this last statement, we'll say 3, part B, the more readily the acid dissociates, the stronger it is. Okay, I'm going to read that again. The more readily that an acid dissociates, meaning it gives away its hydrogen ion, the stronger the acid is. Okay, so if you followed statements 1, 2, 3, and 3b, that gets you to statement 4, which is essentially the most important one to know. The larger the Ka, the stronger the acid. Okay, this one I would memorize. This is a good relationship to know. It's just the summary of points. This is the summary of points 1 through 3b. The larger Ka, the stronger the acid. Points 1, 2, and 3 are explaining why and how we get to this relationship. All right. Let's look at the next table. I feel like I was going to write some stuff in here because I left it blank, but I don't remember what I was going to write, so we'll move on. Okay. Ka values for weak acids. So this is a table of Ka values. You see what acid we're talking about in the left-hand column, and then it's a Ka value. So what scientists have done over time as they've studied the strengths of different weak acids is they've already determined the Ka value for several acids you can see at equilibrium. And those are reported here on this table. This is also in your textbook, and this table will also be on exam 4. Table provided on exam 4. Okay. So if we look at these, you can see there's quite a range of Ka values if we zoom in on some of this. For example, you could have 3.5 times 10 to the minus 4. You could have 1.2 times 10 to the minus 2. Look, you could also have really, really small numbers, times 10 to the minus 13, times 10 to the minus 11. So there's all kinds of Ka values. And these are pretty small numbers, right? But remember our trend. Remember statement 4 up here. The larger Ka, the stronger the acid. So what kind of problem can I ask you about all this stuff? We've been talking and talking. Let's put it to practical use. Well, one type of problem I could say is if we had, I'm going to circle 4 of these acids in purple. I'm going to circle this one, okay? I'm going to circle formic acid. I'm going to circle ascorbic acid. Does that look familiar? That was on exam 3. You're like, don't remind me. And then I'm going to circle HSO4 minus. One of the sulfuric acids. Okay. If I give you these 4 problems, I could say list these acids from strongest to weakest. All right, list these acids from strongest to weakest. This is a perfect example of the type of problem you could get on the homework or on an exam or whatever. So you cannot answer this problem unless you know our relationship that the larger Ka, the stronger the acid. So if we're going to start with the strongest acid, we need to start with the largest Ka. And the weakest acid will have the smallest Ka. Okay? So how do we look at these numbers and determine which one's the largest and which one's the smallest? Well, obviously, remember that in the world of exponents, if it's negative, a negative 10 is smaller than a negative 2, right? Negative 10 is smaller than a negative 2, 10 to the power of negative 10. Smaller than 10 to the power of negative 2. Okay, if we had 10 to the power of negative 10, that would be 0.00003, 4, 5, 6, 7, 8, 9, and then we would have some number here. Okay, if we have 1.2 times 10 to the minus 2, that would be like saying 0.012. This would be like saying, well, we'll just write out the K value. If we were looking at an ammonium here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 5, 6. Okay, so these are up here. I wrote these values out in decimal form. So just remember that. All right, so the largest, we have a 10 to the minus 10, 10 to the minus 4, 10 to the minus 5, and 10 to the minus 2. So the largest K is definitely 1.2 times 10 to the minus 2, which means HSO4 minus is our strongest acid. Okay. Next, we need to look for the next largest Ka. So we have 10 to the minus 10, 10 to the minus 4, or 10 to the minus 5. And it should be formic acid. So that is our next strongest acid, HCOOH, because its Ka value is the next largest. 10 to the minus 5 is larger than 10 to the minus 10, so our next strongest acid is ascorbic acid. We'll just write vitamin C, ascorbic acid. And that leaves the last one to be NH4 plus ammonium. The ammonium ion is the weakest acid here because it has the smallest Ka value, 5.6 times 10 to the minus 10. So that's an example of a problem that I could ask you. I could also ask you to order them from weakest to strongest, and so on and so on.